All right, I guess you can see my screen, right?
Yep.
Okay, so let's get started then. Hello, good evening. Welcome to this meetup for the month of March. It's nice to see all of you here, and hopefully you're going to enjoy today's session as usual. Today we have two speakers. One is from Grafana Labs, and the speaker's name is Ed. I'm going to introduce him briefly later on, and also when we get started, he will introduce himself. But before I let Ed present, I'm just going to briefly introduce the meetup, especially for those people that may be new to our group. And then after Ed's presentation, I will also present. So basically, we have two presentations for today. But first of all, I'm just going to introduce the group. All right, so our name, as you know, is Kubernetes and CloudNative, not Dallas. We are part of a global group of meetups being organized by the CNCF Foundation. And I'm going to show you that in a moment. So if you go to cncf.io, you will see on their webpage, you see our meetup is right here, Kubernetes and Cloud Native North Dallas. And so we are part of a global group. And for those of you who don't know about CNCF, this is the body which is responsible for maintaining the Kubernetes infrastructure and a whole lot of other applications within the CNCF landscape. In fact, if I go here to what we call the CNCF landscape, you see a lot of projects which they do, and Kubernetes is just one of them. All right, so what I have here is called the CNCF landscape. On it, you're going to see a whole lot of applications that CNCF support. Now, all the applications you see here, some of them are still undergoing some process. So it's not that CNCF is hosting all of them as of now, as of today, but the ones that they are hosting, you will see them in blue, highlighted in the square, with this blue color. So any of those you see like this one, Vitesse, KV, Helm, and if you come down here, you see where Kubernetes fits in. So they maintain a whole lot of these applications. So the aim of CNCF is to have a body that recommends the best of the best within the open source ecosystem. So when you start to implement your cloud native environment, you're going to come across so many tools that are being used by different DevOps teams. And sometimes it can be overwhelming to even know which of these tools are best for your team. But if you are coming from an environment where you're already using some of these tools, then your life may be easier. But for someone who is starting from scratch, sometimes we want to know which of these applications are better than the others. So that is just one of the objectives of CNCF, to give you a trail of applications that they think are the best within the open source community. And like I said, Kubernetes is just one of them. And Grafana that Ed will be talking about, you will see it if you look for it. I'm sure you also see it somewhere within this landscape. All right, so within our meetup, we can basically talk about any of these software or open source applications that you see right here. Like I said, today Ed will be talking about Grafana, which is just one of this whole lot that you see here. All right, so as far as the meetup is concerned, the sponsors, we have one of the sponsors, and I'm from Cloud Technology Experts. And as a matter of fact, this meetup, you can say, is being sponsored by Cloud Technology Experts. And then we also have Brent that helps out. And then Himansu is also here with me, who has been, very helpful in helping to organize the meetup to ensure that, everyone have a good time. I always announce that if you need to help with the meetup, if you have some time to dedicate, please feel free to contact me, and we'll try to get you involved as well. This is a community effort. It's not, it's mostly just a community effort. So feel free to come to share your knowledge, to share your time, to help out organize. All right, so I'm going to be presenting, so I won't take much of your time. But basically, the Cloud Technology Experts, as the main sponsor, we do mostly online training. Um, so some of the things we'll talk about today, like Kubernetes security, Kubernetes administrations, AWS, microservices, DevOps. These are some of the things we train on, and we're going to be available both online and in classroom. Okay, so a few announcements. I already announced that we always need help. We always need speakers. But other than that, the next meetup is going to be on April 21st. And if you have something to share with the group, feel free to let me know. For today, our speaker is Edward Welch, and I'm going to pass over to him, and then he will introduce himself and then do his presentation. He advised that we leave all the questions till the end of the presentations. So if you have any question to ask, feel free to put it on the chat line. But once he finishes, we're going to have a dedicated Q&A time for him to answer your questions. And then shortly after his presentations will be my own presentation. So until then, I'm going to pass over to Ed, and he will take over from there. Okay, so first let me stop sharing, and then let him share.
Okay.
Okay. I've actually not seen Ed. Okay, all right, down here. Okay, 1 second. Okay. Ed, can you try to share now?
If this works.
Okay, so I'm gonna add you.
There we go.
All right.
All right, thanks, Damien, and thanks to the Kubernetes North Dallas group for having me on to talk about some logging sort of tips and tricks and things. Yeah, throw questions in the YouTube chat, and I'll answer any at the end. But really, I'm here just to kind of talk about some things about Loki, the project that I work on. Give you kind of an introduction to that, and talk about how it can be useful for. Start my timer here so that I can keep some semblance of order to this. So it's going to be, I want to talk about how Loki can help, for example, this kind of a problem, right? So we have lots of logs. We have lots of logs with lots of data, and it's often kind of hard to see what's inside of that. So what if we were able to take that log line and just restructure it and pull out the relevant pieces of information, display them in a nice oriented fashion? Might be helpful, right? So what about if we had a different source of data, log lines that maybe have some content in them that we want to maybe visualize and turn into a graph? So I'm going to talk to you about the Loki project today and how it can be helpful in basically creating these kinds of graphs and outputs. And additionally, just some kind of experience that I've had throughout my career. My name is Ed, and I'm an engineer, manager, and the Loki tech lead at Grafana Labs. As I mentioned, I want to talk about logging, talk a little bit about the problems that we face around logging, talk a little bit about how Loki can help with that, and then throw in some of my own experiences at the end. I'm going to try to sneak a demo in here too along the way. Hopefully we can fit all that in a reasonable amount of time. So if we kind of go way back to the beginning and we talk about the source of the problem, logs themselves, the most basic thing that almost everybody learns when they're programming is kind of a hello world example that usually evolves into, communicating some sort of state out of our application, starting and stopping and processing. And then it kind of devolves into this sort of I log what I want, whenever I want, however much as I want. I think the interesting part of this is we don't really have a lot of education. There's not, at least in my experience, there's a lot of university courses on logging best practices. A lot of companies don't necessarily have anything on logging best practices, and so we end up with the beginnings of a pretty big problem here, right? Where everyone sort of logs according to their own styles, and it's sort of makes a challenge for us that are trying to do analysis and operations of systems. But there's other problems here too, where not everything is a log that's, say, created by a developer building an application. We have things called access logs. We have things called audit logs. We have to store and process those. We do that, and more increasingly so for automation, generating reports on our data, security analysis. There's lots of sort of machine use cases around logs. And as a result of that, we've started to see a really big increase in structured logging. The authoritative source on popularity, a Google search history, shows JSON logging is more popular than ever. And I'm kind of here to talk about the problems that we now see as a result of that. So I think when we look to adopt structured logging and JSON logging, we lose kind of the human aspect. An example of an Nginx access log in both kind of their common log format, which is basically space delimited, which is fairly human readable, and to the JSON equivalent, which is a little harder to read. And you're probably saying, Ed, you can pretty print that, right? And you absolutely can. But then I think you've created a different problem where you've taken a log line that initially was maybe one line if you have a big enough monitor, and you've made it 20 or 30 vertical lines, and as a human processing that information, creating that vertical space sort of creates a different challenge, right? Like it's a lot harder to look through logs quicker. So there's challenges here, right? And it doesn't get any better. It's this is an access log of some kind from, looks like GKE, and where do you begin, right? How do you start? So I'm gonna tell you how I think Loki is possibly a useful tool that you can put in your tool chest for helping with these kinds of problems. If you're not familiar with Loki, Grafana Labs has created this. It's a horizontally scalable, highly available, open source, multi-tenant log aggregation system that's sort of heavily inspired by Prometheus. And it was created, I think, because, and maybe exemplified in this sort of, tweet, with a little exacerbation around, moving from a world of command line and SSH, where it was actually not that bad, and the tools we had at command line were pretty good at processing our logs, to web-based interfaces and aggregation to solve this problem of growing scale that maybe left a little bit to be desired. And another use case, right? Operations getting paged and being able to quickly move between your metrics and your logs to help find a problem. So this is where Loki was really built and really targeted. We wanted to have something to make the developer and operator experience around logs better. The project itself was incepted just about 3 years ago in March of 2018. It really started building development momentum roughly 8, 9, 10 months after that. This is about when I started getting involved with the project. I'm not saying that that's the reason for that, but I've been doing this for just a little over 2 years. And just last October, we did the 2.0 release of Loki, which included a number of, I think, really powerful query time tools that we'll talk about in a bit. And we did 2.2 last week, which is added a write-ahead log and some other tools for increasing, durability and operations. So from a maturity standpoint, I mean, this slide mostly exists to sort of explain the history and the fact that I feel like at this point, Loki is a reasonably mature, high-performing product. And I want to kind of talk about the things that I think make it my favorite. Obviously, my opinions here are biased, but hopefully you can see where I'm coming from here. Talk about the query language a little bit. So this is an example of some of the functionality within the query language. It kind of breaks down into a few sections: parsing log content, being able to do some more complicated filtering on that content or the labels on that log line, and then reformatting it like the example I showed initially, and even then doing things to extract data out and turn them into metrics. And if you're familiar with Prometheus, these functions will look very familiar to you. And that was definitely by design. I always forget this. So what does that end up looking like a little bit? So in trying to maintain that feel of grep, you have some basic expressions like filter expressions. And this is saying, show me all of my distributor logs from the ops tools cluster that have an error message. or the word error in the line and don't have CAS, which is a compare and swap operation. So that's an example of, and you can sort of chain these together to add and remove as many elements or lines as you want. You can also take, so this is our ingress logs on JSON format and run them through a JSON parser and then say, only show me the log lines that have a response greater than 10, response time greater than 10 seconds. And then maybe I want to start looking into the world of visualizing things over time. So show me the rate of error messages for an entire cluster, summed by pod. Or, you know, I can really get out into the deep end of metrics and say, show me the 99th percentile quantile. I always say that wrong, but for push requests where I'm filtering on a specific org ID and you know, looking at that 99th percentile over time. So that's just a little bit of a hint or a glimpse there. We'll probably touch back a little bit on the query language in the demo. Second thing about Loki that I think makes it really powerful is the sort of lack of opinionation that we have on the structure itself. Basically, I don't really care what format your log is in. You sort of point it at an agent. I'll show you a list of those later. And there's from that's really it. The goal here is to have sort of as little overhead on the ingestion side as possible. And that means there's really no internal schemas for Loki. You know, you don't have to worry about kind of changing, you know, data models over time. We just want to ingest your logs and store them. And then, you know, the design decisions that went into Loki also, I think, lead to some nice operational aspects too. And that's what I want to dig into first, which is how Loki really works and what is kind of the biggest design decision that went into Loki, where Loki does not do full text log indexing. So we don't index the content of the logs. And that's what gives us that flexibility of ingesting logs of any format, because we're just going to store them as a string and then compress them and store them in an object store. And then for accessing those logs and finding them, we build an index around labels. And this is why Loki got the tagline, like Prometheus, but for logs, because it takes the same Prometheus label model and applies it to logs. So it's some metadata that we can add to the sort of the origin of these log lines to be able to help find them again. And this has some very nice operational aspects to it. Reverse indices, you know, typically found in search engines are really big. You know, like you have to sort of, you know, keep an entry for every word or word is good there, right? For every word in your log line in your index. So Loki takes a different approach. I've taken to kind of calling it more of a table of contents. So we're just keeping that metadata that points to where that log came from, so we can find it again, and it gives us a nice balance here and from one of our ops clusters where we ingested about 10 terabytes of logs. I looked to see what the corresponding index size was, and it's about 200 megabytes. So you can start to see, you know, loading a 200 megabyte index into memory to be able to, you know, address and search 10 terabytes of logs isn't too big of an ask, right? And so this is going to, you know, help us scale Loki to a lot, you know, bigger extents, a lot less sort of painfully and more affordably. And then on the log side itself, we just zip stuff up with a few different options that are configurable for compression and storing in object stores. So object stores have really kind of proven themselves to be, you know, fast, affordable, you know, handling large amounts of scale and relatively inexpensive. So Loki's really a logs database that's built and optimized for storing in an object store. The label piece of this has, you know, ends up being very important, and it is, I think, a little counterintuitive. I've had a couple of blog posts and, you know, over the years have been trying to find the right messaging here, because I think there's a couple of reasons why it's a little bit tricky. And one is, I think labels themselves are actually quite intuitive. You know, it's very easy for people to understand how to add labels to their query and to use them. However, and I guess the second part of that is most people's experiences with databases usually go something like, you know, if it's slow, you add more to the index, right? You index more data and it speeds it up. And it's actually really quite the opposite with Loki. We do better with less data in the index. The smaller that index is, generally the faster we can make Loki perform. So there's a little bit of a mindset here that's important to kind of, you know, think about. And that's kind of why this slide ended up in here. And think that hopefully everybody's asking me, okay, what's the catch here, right? Like if we don't have a big index and, you're telling me that it's faster with a smaller index, like how is that possible? And the answer looks a little bit like this. It looks like me drawing arrows in a Google PowerPoint slide here for like 35, 40 minutes. But I think gets the idea across reasonably well. We can basically parallelize queries highly effectively. So we can split them a couple ways. We split them by time. And then we also split them based on a sharding factor. And what that means is, I don't need to know exactly where in S3, like the exact chunk and where in that chunk the log line that I'm looking for is, because I can narrow it down to, 10 gigs or 100 gigs and search it all in parallel. And there's some really nice benefits of this as well, because I have control over that parallelization. So this is showing 4 queries with 4 cores doing, basically 16 units of work in parallel, but nothing stops you from adding, 12 more queries and cores and doing this whole workload at parallel. So that is a sort of a knob you can tune then to figure out what level of query performance is useful for you versus the kind of operating cost model that you want to have. So let's talk a little bit about some of the other fun things Loki can do. As of 2.0, Loki supports directly writing to the Prometheus Alert Manager. It includes a ruler, which you can write Prometheus-style recording rules. Or I should say alert rules. Recording rules are coming soonish. And we'll be able to write logs into remote write into metrics database, but I'm kind of maybe talking about something that's not quite ready yet. But from a recording or an alerting rule standpoint, you can take a normal Prometheus alert rule format and insert log QL queries. Gives you kind of an interesting and maybe a little bit of a neat feature that isn't something you might be able to do normally in Prometheus. Like this is an alert on aggregating on a remote IP address. It's kind of a contrived example. It's maybe not a good one, but because we're not indexing the the high cardinality piece of data, the remote address, we're just sort of reading it as it's streamed into Loki. We're able to do things like alert on it, which is a little bit hard to do sometimes in Prometheus. Loki as a entity, I guess you call it, is a single binary. We compile it into a single binary, and you can run it just by basically /Loki, give it a config file. This is how I run it on a few Raspberry Pis around my house. But also it's the same binary. You take, there's a target flag that you pass to it, and that lets you run it as its sort of component microservices, which is where you can build it into the sort of cloud native thing that I alluded to, where you can scale read in, write paths separately. It scales horizontally really well. The write path is sharded with a distributed hash ring, so that as you add ingesters, the load becomes sharded over them. Query path can be scaled separately from the write path, so you end up with basically your fixed cost, your write path being kind of scaled to what is necessary for your workload, and then the read path is under your control. And number of agents available, Promptail and the Grafana Cloud Agent, which is now the Grafana Agent, which really is a slimmed down Prometheus sort of scrape and remote write without querying capabilities, and it actually embeds Promptail, and that's kind of a nice way to sort of send your logs and metrics somewhere if you need to, I guess. But we have a number of other output support for FluentBit, FluentD, Docker logging driver specifically. There is a CLI, which can be really handy for those of us that really like working from a command line, and it works in a way that you can just pipe that output from your CLI into your other command line tools. It supports live tailing, both from the CLI. It's kind of boring having a snapshot of a live tailing screen, so I can demo that in a second, but we can live tail your logs in 1 or 2 seconds delay. Typically it's usually how long it takes for our batches to send from Promptail. Nice demo time. Whoops. All right, so the screen that's reasonably big. Take a sip of water. So the query language is that the idea of these labels. So I can look at, what was I going to look at? Let's look at Central 1, and let's look at, we use a job label internally at Grafana Labs, and it's a combination of namespace and workload. In this case, the workload I want to look at is distributors for Loki. So Loki by default, I spelled something wrong. Not distributors. By default, we'll just return the first 1,000 lines. And typically the way that I then work around this depends a little bit on what I'm looking for. So let's say maybe I'm only looking for errors because I'm trying to figure out what went wrong. So I'm just going to do the equivalent of like a grep for error. And that should then return a smaller list of data. So in this case, I got a bunch of these check or compare and swap errors. So I think one of the things I end up doing a fair amount is trying to understand the origin of an error like this. So I'm going to say, let's just look for just those compare and swap errors. And this doesn't immediately tell me anything useful, but when I start looking at something like this, let's take a look at the rate over bigger. And I'm just going to aggregate because I don't really care per pod at the moment. And I can say, okay, show me the the rate of those error messages over the last 15 minutes. So what I'm sort of question that I'm trying to answer to myself is, say I just got a page and it's like, is this error new? Is it related to this page? Maybe more interesting to look out a longer period of time. So this is a reasonably hefty query for Loki. Our distributor logs are, the 15 minutes was about 3 gigs there, I think is what it popped up. So we'll let this chug for a second. And this is a good opportunity to, let me open a new window. So I think one of the kind of more fun use cases that we find for Loki is a little bit more in the analytics side. So I'm going to look at a different cluster because I want to look at the cluster that was running that query. And I want to look at the query front-end logs. But they're going to be a little bit noisy. So there's a particular log line that we output for every query that's processed. And I'm going to parse it with a log format parser because that's the format these are in. It's a key value format. And specifically, I want to look for only log lines that had the query that I just wrote. It's going to narrow this down. So I'll just do a regex max match on the query containing the word query. And this is that query that I just ran. It looks like it did finish between the time that I did. Yep. So it took us about 30 seconds or so to process the last couple of days of metrics. So Loki is not a metrics database, but I can definitely use it like one. It's not going to be quite as fast, but we still did a respectable 13 gigs a second on that query, about 368 gigabytes of data to process that. So I think kind of the moral of that story is like, we even without a full reverse text index, like, sort of parallel computing and kind of even the cost structure here, right? So that query cost is the compute that it took to decompress the stored data, and then the IOPS for reading from GCS. We don't really have to pay network transfer because we're running within the cluster. And, IOPS are, 4 thousandths of a cent per 10,000 requests or something like that. So, it's not too bad, right? So like it's a pretty decent trade-off in my opinion to sort of throw a little more brute force at this kind of query rather than having an index, because the other side is this 300 gigabytes of data has like 1 or 2 megabytes of index footprint. So let's see what time I'm at here. Oh, I lost my time window. All right, so let me park this and go back to the second part of this. So quick Loki, we'll see what time we're at when I get through the last bit of the slide. So that's just kind of my high level overview of Loki. I think kind of a fun look at Loki as a tool. I want to talk a little bit now about not specifically Loki, but just some general advice around logging. this is sort of stuff I'm kind of putting together over time. I've spent a lot of time with logs. Previously in my career, I've actually spent a fair amount of time with logs, and there's some sort of advice here that I think could be helpful. The one first thing is, the title of this talk, logs are for humans, right? I actually think that's true. I really think logs are really built. Humans create them for the most part, and we consume them. But we really can't do much with them anymore without machines, and machines can't do much with them at all if we don't structure them. Loki does have a regex parser you can use, but regex is not the fastest way for a machine to parse logs, and that's true with Loki. And regex is not particularly fun to write. So if you're going to structure your logs, I like log FMT, log format. However, if you're not in the Golang ecosystem, this is not going to be nearly as accessible, and likely it's probably not something that most people are familiar with. But if you have the opportunity, I think it's a nice combination of being human readable and still, fully structured and machine parsable. Excuse me. JSON is obviously the sort of, 1,000-pound gorilla here or whatever. Like it's the most accessible, works really well. I just have a couple of my own experiences here that I would add is it gets a lot harder to use JSON when you log really big complex objects with multiple nested fields or with arrays. If you can avoid doing that, please do. Those objects are not human readable. Pretty printing sort of, in my opinion, makes the problem worse because you've now taken something that's, one line and made it 100 or several hundred lines. And as a result of this, we have tools now. We've built entire query languages for accessing elements of JSON. So, now we're sort of embedding some of these within Loki 2 to sort of help with this problem. And it's kind of an additional level of complexity that you can avoid if you keep your objects flat and you keep them short. Not always possible, not always the case, right? That log I showed you before is created by Google, but Loki is at least able to help us here by extracting out relevant fields and reformatting stuff. So it is workable. When it comes to log levels, my advice here is I would say, I don't know, take it with a grain of salt in the sense that everybody, can have some different opinions here. I'm not meaning to say that I'm sort of right or wrong, but I feel like this has worked pretty consistently for me. It's oftentimes tough to make this consistent amongst applications and organizations, but if you can add consistency to your log levels, it can help a lot. I like to consider the error log level specifically something wrong with my system. This is the kind of log that I want to look for. I want to search for error when I'm trying to find a problem in my system. If I'm getting paged, this is where I want to look. Warning log levels are, to me, something that's wrong with somebody else's system, the data that they're sending, something's wrong. This is the kind of information that I would use to help someone else solve a problem. And when I say someone else, it's usually probably like at an API boundary or something like that, right? And then, info log levels are, I think, should just sort of generally be not overly verbose and give you some overall communication state. I also have found that adding some kind of a heartbeat or logging your health checks is useful as well in terms of kind of knowing at what point an application may have become responsive or unresponsive or just totally disappeared. And then, debug log level is kind of all over the place. I will say that, at Grafana Labs, we run debug logging level on all of our clusters in all of our environments, including production. Hopefully a tool like Loki enables you to do that in a way that's still manageable. And, I tend to think of the debug log levels as really the sort of the story of an individual process or an order. They can be incredibly verbose. I mean, we were looking at distributor debug log levels that, logged hundreds of gigabytes over days, but that kind of information can be really valuable. It doesn't necessarily even need to have a long retention, but it's very valuable in a short period of time. My bonus here is if you can include statistics, so we've started building out these kinds of log lines which contain data like this, the query time, the throughput, on push requests, the number of streams, et cetera, because Loki's really good at being able to extract that data out and showing it to you in a graph and even showing it to you, by org or by tenant. And that can be really, really useful for kind of finding things that fall in between the cracks in metrics. And a kind of a further thought here that I would throw is, you know, the way that my mind shift or mindset is shifting around log level is more to do with maybe the stream concept within Loki, because for me, we use log levels to sort of kind of quickly turn on and off certain things. So we don't set a label for log level. We actually just have a label that says debug equals true, because our debug log levels are several orders of magnitude, you know, more verbose than everything else. So what I really want is just to sort of quickly filter out the debug log levels so that I can see those info, warn, and error log levels. You know, if you had really verbose warn, error levels, consider, you know, a similar strategy. Use labels to be able to kind of control how you would query them, as well as thinking about how you might do retention differently for them as well. My favorite picture from this is, you know, I feel like if you went and you look through your log systems right now, you know, looked at your logs, and, you know, every log line that you find that doesn't have an order ID, a trace ID, a request ID, some UID in it, isn't really have any value at all, right? Like that log line is wasted space, because at best, in a distributed system or a multi-threaded system, you could sort of align it on time and look around other logs, you know, but you really want every log line to have that unique piece of context in it. Trace ID is a great one for this. And then you can just write a query in Loki that says, or any system, right, that says, show me all the log lines that have this trace ID in it. And that's a really powerful way to actually see the story of the event that you're looking for. If you don't have that context, it's really, really hard to piece those back together. Another, I think, you know, these last two, I think, are the kind of strongest opinions that I have here is, and maybe the most actionable too. This one specifically, like when you're doing a PR review, if someone has a log line with an error message in it, and that error message doesn't have an action on what you should do when the application spits out that error message, should ask the person to add something, because you know, there's almost nobody that's going to have a better idea of what action should be taken than the developer that creates the error message in the first place. And these effectively become your run books. You know, that workflow I showed in the beginning, where you get paged, you go find some metrics, you pivot over to logs, you look at those logs, you're going to see some error messages. It's really nice. I could say this was an example, right? I got a page, I pulled up the logs, and it's full of cannot allocate memory, and like my heart sank. I'm like, that sounds terrible, right? You know, and after some digging around, it wasn't really that bad. A node had basically run into memory pressure. It was struggling to allocate or to have enough memory, and Kubernetes said no problem, just started booting some pods off of it. And then the system that generated this message basically retried writing the checkpoint for the write-ahead log, and everything went on its way. But, you know, for a good 5 or 10 minutes, I was kind of really unhappy and really concerned. And it would have been nice if the log message just said, check this, and here's what'll happen next, or here's what you should do next. So if at all possible, this is kind of a nice sort of training for anybody to make sure your error messages have an action. And the quick summary of that is they got to be structured. You can pick your poison there, but really, you know, we have so much sort of need for machines to work with our logs that they really do need to have some kind of structure. If you can keep those objects flat, those structures simple, I think it makes your life easier. Log levels, you can kind of apply and use whatever you think makes the most sense, but the closer you can get to consistency, easier. That's a hard one though. Context on every log line. Errors should have instructions or actions. Those are the kind of the really important pieces, I think. So that is the end of it. But I wanted to, well, let me see. What time is it? Let me check for some questions. 5 o'clock.
All right. So you're done?
Yeah, I think so. I don't know how long that took. My timer disappeared.
All right.
So I feel like it was probably plenty long. So yeah, let's say that I'm done. If anybody wants to reach out to me, find me on our Grafana, slack.grafana.com as ewelch. on Twitter, on GitHub as Slim Bean. I've made a project that I thought was kind of a fun way to get started with Loki. If you just search for like Loki shell, you can find it too, which is storing all of your shell history in a local Loki instance to be able to combine that with FZF, which is a really awesome addition for your command line to have infinite shell history and be able to extend it to multiple computers, and kind of a fun way to play around with Loki. So, but yeah, thanks.
We have one question on YouTube. Question is from Yashwant, and he would like to know how are the logs indexed based on time, cluster?
Yeah, absolutely. So that's the label part. So that's the like Prometheus but for logs. So those that labels are metadata that you assign the agent that collects the logs would assign to them. So as a whole, Loki is very unopinionated about the ingestion of logs, but when it ingests them, it's going to assign some labels. So in Kubernetes, Promtail actually gets its name from Prometheus because it uses the same service discovery library that Prometheus uses. And you can then actually use the same scrape config or very, very similar scrape config that what you used Prometheus. So it's going to query the Kubernetes API and come back with information about the pod and the pod template hasher, et cetera. But what we tend to pull from those are the namespace, the cluster, the pod, and we assign those as labels. And that's what ends up getting indexed, and that's indexed by time. So that way you can, for a given time range, look at and find the logs for a specific app.
Okay, that's nice. And I think there is a follow-up question from Yashwant. Even if there is a good log parsing, as you mentioned about uniqueness, how is it done with Loki?
I don't know if you can hear that. There's a helicopter flying over my house. Some more questions coming in. I'll see them here. So let me move them so I'm not looking off the corner of my screen. How is it done with uniqueness? So when it comes to parsing logs, I will say that areas that we definitely want to see improvement over time. You can use JSON or log format or regex parsers to normalize the content from the log lines, be able to rewrite the log line into a format that's more readable. It gets tricky when you have multiple applications at the same time you're trying to do this with. The way you handle that would be something like Explorer. You can write separate queries and then the results get interpolated. So you can basically write a separate query. We use labels to narrow the app down and then write your query to give you some sort of a normalized output. And then that can then combine multiple log streams into sort of one view. I see how our Elastic and Splunk are complementary. Elastic and Splunk are search engines. They're very good at what they do. Where I think Loki is a differentiator is it's sort of solving a different problem. We're not building a search engine. We're really just building a large scale categorization and storage engine. So we're going to take those logs, store them, kind of inexpensively as possible. So we don't really worry about hot and cold storage tiers. Everything just goes into an object store. The trade-off there is the analytics use cases, especially Splunk and Elastic have many years of experience here as well as development. So they're a lot more full featured around being able to do a lot of analytics use cases. This is an area that we're improving with Loki, but really the tool has been built and we're targeting these sort of operations and developer use cases. But as time goes on, I think we can get better and better at that. Similar question. Docs seem geared towards the split indexes versus chunk store. Yeah, it's a good question. Between the wrong place or bad docs, it's probably both. But yes, in the pre 1.0 days, we ran Loki or pre 2.0 days with we used a separate index like Bigtable, Cassandra, or DynamoDB, and an object store. And then in 2.0, we use BoltDB as our index, but we just store it in the object store. So I would hope that most our docs steer in the right direction, but I wouldn't be terribly surprised. Documentation for Loki it's a decent technical reference if you know where to look, and I feel like that I find myself as probably the best search engine for that, and that's a problem that we really need to improve on so that other people can discover and self-serve better. So so a good question, Nathan. If you can't find stuff, there's community.grafana.com where we watch for questions. I can happily answer there, or slack.grafana.com, and there's a Loki channel in there, and we can certainly help steer you in the right direction. Thanks for the questions, everybody. I actually really appreciate it. It's really exciting. Good questions.
So, Ed, I have one question. So, how did you guys come up with this name, Loki? What does it mean?
It wasn't me. It was before I started with the project, and I believe probably the answer I should say is it's following in the spirit of Prometheus and Thanos and other Greek gods. Apologies if it's Norse, but I believe it's Greek gods. So yeah, that's the general. That's
reason. What I guessed. Okay.
Somebody asked me not long ago, like, why did you name it after the god of mischief? And it kind of made me laugh because I don't know, like I'd never really thought about it, but it's like, why would you name your useful, productive logging tool after the god of mischief? Like, it's not because we lose logs. We're pretty good at not doing that, but I don't know. Maybe it's because of our terrible docs.
Good, thanks. Yeah, I think this was really very informative. I didn't really know personally that something like that really exists. I'm really very excited to actually go and look around and see. Seems like really very slick.
Yeah, absolutely.
For sharing.
Thank you.
All right, thanks.
You mentioned part of why we lose.
Where's that coming from?
I think that's Matt. Matt, your audio has a real weird sound to it.
Okay. Were you trying to say something, Matt?
No, it's bad. It's okay.
Okay. Yeah, it's really bad. All right. Thanks, Ed, for the presentation, and I hope everyone got something out of it. So Matt was trying to say hello. He came with Ed, and so he said that if you need to reach them, he's going to provide his details to me, and also the slide that Ed used will be available. So if you need to contact them anytime, feel free to do so. And also, he would like you guys to let us know if you like the presentation and if you like them to come back for similar presentations in the future. So we don't have a survey set up, but feel free to send us your feedback. You can send them to my email, to Himansu, or to any one of us here on the screen. But other than that, I think we're done with Ed. Again, thanks, Ed, for coming. And now I'm going to do the second presentation for today. All right, so basically, I do realize that in these meetups, we do have new people coming in every time. And at the same time, we have people that have been coming for some time. And apart from that, we also have people that are quite knowledgeable with Kubernetes and the CloudNative ecosystem. And on the other hand, we have people who don't even understand what Kubernetes is all about. So in my presentations, I try to make sure that at least we're all clear on the basics. So that is what I'm going to try to do tonight as I present this topic. It's not going to be too long, but enough to give everyone maybe to scare everyone, to take security seriously within the Kubernetes ecosystem. So my aim is to at least inform you to the extent where you start to take Kubernetes security serious. So I intend to give a couple of these presentations. So today is going to be just one of them. In the subsequent meetings, I intend to, take one of these topics one at a time and try to deepen into it, kind of like go a little bit deeper. But for today, it's going to be more like kind of like the general survey of what you need to be aware of when it comes to your Kubernetes deployment and the security around it in general. All right. So like I said, mostly it's going to be overview, making sure that everyone, no one is lost. So I'm going to take it easy and slow and steady. So we're going to start with this slide. And along the line, I'll come down to talk about some or most of the basics that you need to understand. So the architecture we have here, actually, that is not a Kubernetes architecture. Let me just call it the security architecture, something like that. So this drawing we have here illustrates how the Kubernetes infrastructure is structured. And again, if you're not familiar with what Kubernetes is all about, I'll come back to that in a moment. But for the sake of what I want to be talking about, we're going to use this diagram. If you like, call it a shell. Okay, it's like a shell with the innermost layer called here the code. Then next to it is a container, then the cluster, and then the cloud or the co-location or the corporate data center. Interestingly, if you look at this closely, each one of them starts with C. So you can call it the 4C of the Kubernetes architecture. And when it comes to security, this is how you can view it. This is how you can try to imagine how the platform, the Kubernetes ecosystem looks like. So let's start to understand this, and then I'll go ahead to, at the same time, try to explain some of the concepts we're talking about here.
Damien,
So,
are you sharing your screen?
Oh, okay. Maybe I'm not. Wow. Let me just share that quickly. Thanks for letting me know.
Oh, no problems.
Okay. Share screen. Okay. So I was talking all to myself. So you can see that, right? I try not to present full presentation mode because I'm using two screens. And when I do that, sometimes things tend to fall off. Okay. So this is what I was talking about. So if you can, as you can see on the screen here, we have 4 layers. The innermost layer called the code, followed by the second layer called the container. Then we have the cluster, and then we have the cloud, colo, corporate data center. And what I was trying to say is that each one of these starts with a C, so you can say the 4 C's of your Kubernetes cluster. And that will help you to see how the security here works. Okay, so at the innermost layer is the code. This is the code that the developer writes. This is your microservice. Okay, so what is Kubernetes? Kubernetes is a platform for deploying your microservices applications. And what is a microservice? Well, to understand microservices, we need to talk about monolith. And we have given several presentations on this. So let me see if I can find a slide just to quickly illustrate the concept. Okay, so here we go. And like I said, this is kind of trying to bring everyone on speed at the same time trying to talk about what I'm trying to talk about today. So here's a monolith application. As you can see here, this application has different components. For example, if you take this to be your ride share, like Uber application, this application here has different components, right? It has the component here, which is the interface for the passengers or the customers to use the application. Then you have the web part of it, the UI interface. Then you have the component responsible for payment. Then you have another component for sending emails, on and on. But the thing here is that in terms of how this application is written, everything is written and compiled as a single binary. Now, if you contrast that to a microservice application have different components, okay? Each one of these applications components that we have here is decomposed into a separate application. And so each one of these applications has been developed as a separate application, a separate autonomous application. So while here we have a single binary, in the microservices architecture, we could have up to 1, 2, 3, 4, 5, 6, 7, 8. We have 8 microservices, right? So this application is going to do exactly the same thing as this. However, this one is more suitable for the cloud environment. And people have come to realize that anytime they're trying to migrate the application to the cloud environment, they have to convert the application from monolith to microservices architecture, where they have to take this application and split it into different components, and then the developers will write the application as a single, as a autonomous kind of individual applications, and each one of those applications have to communicate with each other. Now, this concept is very good, but it has a lot of challenges, and the challenges are the main reason why Kubernetes exists, to help you do all the management. That is what we call the orchestration. So Kubernetes will help you to orchestrate this entire environment. That is, it will manage it. So see Kubernetes to be like your cluster manager that will ensure that these several suite of applications are all working effectively as if it were just a single monolith application. Okay, so that is a microservice. So if we come down to the diagram where I was showing you earlier, the innermost layer here is your microservice. You write a microservice application, and then in writing your microservice application, from the security perspective, you have to make sure that your code is well written. Some people write codes, but their codes may not be very good. Maybe they are leaving out some holes for maybe buffer overflow and stuff like that. They are making an application which is easy for people to, inject some script or whatever the case might be into their code. All right, so that is it with the code. But at the same time, your code has some libraries. Maybe those libraries are coming from open source. Maybe they are coming from Loki. Maybe they are coming from Grafana, maybe from Prometheus. A lot of open source applications are being used in conjunction with this. So all the libraries you're using, from a security perspective, you need to ensure that all the major vulnerabilities, the CVE, that are known for the applications are checked and are correctly, have been corrected. Otherwise, how can you be sure that your code itself is going to be secured? All right, so that is from the code level at the innermost layer. Then next to it is a container. The container is where you are actually running your code. So the usual practice is that first, you split your application into microservices, and I'll go back to the diagram here. You split them into microservices. Then you package each one of these microservices into a Docker image. As you package them into Docker images, then you want to now run this Docker image using a Docker container, for example. I'm just using Docker, but there's a few container runtimes. So you package your application, that is your microservice, into a Docker image, and then you send the image to a Docker registry, some repository where all your images are stored. Only after you do that can you now run your microservice application using Docker. Remember, Kubernetes is just the orchestrator for Docker or for container environment. So without your container environment, you don't even have a need for Kubernetes. So before Kubernetes, you have to ensure that your application is properly written and then packaged into an image and then sent to a Docker registry. And then from there, you can now begin to run your application. So that is at the container level where Docker exists. Now at the container level, I mentioned your registry. So you need to ensure that where you're actually sending your image to the Docker registry is well scanned. So most registries are going to be frequently scanned to, detect any security vulnerabilities that may exist within your image. Because as a matter of fact, your images or your registry is a very important component of your microservices architecture. If someone manages to go into your registry and inject some dubious code into your code, okay, through the container image, then each time you run that image, your application is going to be compromised. So you need to, as security practice here, at the container level, you need to ensure that your images are well scanned, okay, frequently. And when maybe infrequent. In subsequent ones, like I said, I could go deeper into some of these concepts. But there is an open source software called Clair, C-L-A-I-R, that is very popular for people to deploy to scan their images. Okay. Again, remember, your images are very, very important. That is where you have to make sure you take care of them, because if someone injects something into it, that will compromise your whole application. So your registries has to be properly taken care of. Another thing to ensure you do is that you need to make sure the operating system that is contained within that container is actually all secured. Okay. For those of you who have created an image before, you know that it's something like this. There's always a line here in your Docker file, and this is on Docker. Okay. Before you create your image, you have to create a file like this, which is describing how you want your image to be packaged. So this file here is called a Docker file. And on this Docker file, usually the first line is going to be from, where you specify the base image. This base image here, again, if the operating system that is contained within your server is not properly tuned and hardened, that could present another security flaw. Okay, pretty much you need to ensure that your base image is also well created and followed maybe the best practices, okay, for making sure that the operating system is secured. And from this, you can have something called the CIS benchmark. CIS benchmark also has a lot of guidelines that you can use to make sure that your images are all properly, created. That is, you have a kind of a checklist to keep ticking them to ensure that your images are all properly created before you start using them in production. And in fact, in most organizations, when they're using these applications or these images in production, they're going to have a lot of guidelines, some well-written guidelines by some security experts telling you what you need to do before this image can be used for production. Okay, so another thing, the third thing that you may want to do with your containers is ensuring that the user that is actually running your application is not running as a privileged user. Because if that user is a privileged user, then someone can easily, well, if there's a compromise, they can easily escalate, or well, in this case, not even escalate. The user is already a privileged user. So that person can do a lot of havoc. Even if the user running your application is not a privileged user, if it's just an ordinary user with not privileged capabilities, someone can still escalate the privilege to be able to do some dubious stuff in your environment. So you always want to ensure that the user that is running that application doesn't have privilege permissions to do anything, if at all possible. Okay, if at all possible, you want to do that. All right, so those are some of the things you can do at the container level. But where we're going to spend most of the time really is going to be on the Kubernetes environment itself. Okay, throughout the series, we may not talk much about the code because the code is what you write. I can only point you out to maybe some static code analysis websites where you can download some tools to analyze your code. But at the same time, most developers already have some tools they can use for analyzing their code. So at the container level, we may not talk a lot, but at the Kubernetes layer here, that is where we're going to spend a lot of time throughout the series that I'll be presenting. Okay, so at the Kubernetes layer, we have the cluster. The cluster is the Kubernetes infrastructure. This is the infrastructure that runs your Kubernetes. For example, I can come here to my system and show you my Kubernetes cluster. Let me see if I can make this bigger. All right, so I'm going to clear my screen, and here, if I do kubectl get nodes, I'm going to see some nodes that are running on my cluster. This is a 3-node cluster. Here's the master node, and here are the worker nodes. Okay, and I'm going to go to show you how the architecture of Kubernetes looks like. Okay, so here my cluster comprises of altogether 4 nodes, 1 master and 3 worker nodes. And so let's discuss the Kubernetes architecture and see how we can secure the components that comprises the Kubernetes architecture. Okay, so while we're here as well, if I see a kubectl get pods -n kube system, you see we have a lot of pods running here. And so this is actually the actual Kubernetes infrastructure that is running. Okay, these are the several components that we're going to start to talk about in a moment. All right. But we have 4 nodes, 1 master and 3 worker nodes. So let's understand the Kubernetes architecture before we come back here. So if you look at the Kubernetes architecture, this is what it looks like. We have what we call the control plane, and then we have the nodes. The control plane is where the Kubernetes API is controlling every other thing, as the name indicates, the controller node. Here is where your this is where your workloads are going to run. Remember, I talked about microservices earlier. If you were to deploy your microservice application, maybe you have your microservice application has maybe 10 microservices. Those 10 microservices are going to be distributed across these 3 nodes, these 3 worker nodes. However, anytime you interact with the Kubernetes API, this is where you are interacting with the controller nodes. So my cluster actually reflects the diagram here. I have 1 master node and I have 3 worker nodes. So we have this command here called kubectl, kubectl. If you haven't used Kubernetes before, this is what you use to manage your cluster. Almost every command has something to do with kubectl. Okay, so it's the tool, it's the client you are going to use for managing your Kubernetes environment. The only other way you can do without using kubectl is maybe you have a dashboard. You are managing your Kubernetes environment from a Kubernetes dashboard. Otherwise, this is the tool you're going to be using. And like you can see, here I have 4 nodes. So this is what we call the Kubernetes cluster. Before you can start to use Kubernetes, you need to make sure that you have it deployed. Okay, once you have it deployed, then of course you can start to use it. All right, so if we go back to the architecture, on the controller node, certain services are installed. So for example, we have the kube controller manager, where then we have the cloud controller manager, we have the kube API server, we have the etcd, and we have the kube scheduler. Okay, all these are deployed on the master node. Now the kube controller manager is the one that handles what we call the Kubernetes controllers. Certain objects in Kubernetes are called the controllers because they have to monitor certain objects to make sure that those objects are always running. For example, so there's something we call the deployment object. If you create a Kubernetes object, deployment object, that object will monitor some pods. It's going to ensure that those pods are always running. And as a matter of fact, when you deploy your microservices, you will normally use deployment object to deploy them on the cluster. Okay, so if you want those pods, okay, when I say pod, in this case, I mean a container. In Kubernetes, they call a container, where they are called pods, but in Docker, they are called containers. So this is going to help you manage and monitor those pods or containers that you're creating within your own environment. Okay, this one here as well, it's called a kube controller manager. And this is very important from security perspective. The cloud controller manager is the one that is going to help interact with your cloud infrastructure. Now, if we go back here to this diagram here, you see that we have the last layer here is your cloud or co-location or your corporate data center. Because at the end of the day, when you deploy your cluster in a cloud environment like AWS or Azure, you want your cluster to be able to talk to certain resources within your cloud environment. For example, maybe your EBS volume. You want to attach some volumes to your Kubernetes cluster. You can go ahead and provision those and attach them here. Maybe your Kubernetes cluster need to use some ELB, Elastic Load Balancer. So your cluster can go to AWS and ask for ELB, and the ELB will be provisioned and given to your environment. So the component responsible for talking to the cloud environment is called the Cloud Controller Manager. Okay. But the kube API server, this is the heart of it, Kubernetes. This is what controls every other thing. You can see that all arrows point to it. If you remove this, you have no Kubernetes. But of course, everything here is important. Each time I run this command here, kubectl, I am directly interacting with the API server. The user has no the user can only interact with the kube API server. And so because it's customer facing, because it's application facing, because all applications and all human beings talk to the Kube API server. So from security perspective, that is the component you need to make sure that is properly secured as well. And we'll talk about those in a moment. Then next to that is the etcd. etcd server. This is a data store. This is like your database, like your MySQL database. This is where all your configuration information are going to get stored. This is where all your data will get stored. So if the Kube API server is important, from data perspective, this is even critically important. And we're going to see how we can protect this as well. The Kube scheduler, this is the one that is responsible for making sure that all your microservices are distributed across these nodes that you have here. Like I said earlier, if I have 10 microservices, my Kube scheduler is going to ensure that maybe 3 are running here, 4 here, and 3 here. Is the one that distributes the workload to the respective nodes. And then on the worker nodes, we have the kubelet. Okay, we have the kubelet, which is the API's agent on the nodes. So anytime you want to create your container or your pod, the API server will talk to the kubelet. The kubelet will talk to Docker runtime, which has to be here. It's not shown in the diagram, which has to be here. And then your runtime will now execute and run your container. So this is another component which you have to make sure that you secure properly. So of all the things I've talked about so far, the ones we're going to concentrate on their security for today is going to be this, and this. Okay, those are the ones we talk about mostly today. And in fact, those are the ones you have to make sure you take care of very well from your deployment perspective. So that is your Kubernetes cluster. And when we come down here, that is the layer that is here, your cluster, your Kubernetes infrastructure. Remember, your Kubernetes infrastructure is different from the applications that you're actually running on those on the infrastructure. So why you're concerned about your microservices, why you have to ensure that your microservices are well written, the images are well secured, taken care of, scanning them frequently. The cluster itself has to be properly secured as well. Okay, and then the final one here is your cloud environment, or whichever place you deploy it. Mostly people will deploy their Kubernetes infrastructure on a cloud platform, or they might want to run a managed cluster like EKS on Amazon Web Services, okay, or Azure containers and stuff like that on Azure, okay. So when you run your environment on the cloud infrastructure, you also have to make sure that your security at the infrastructure level or at the data center infrastructure is well taken care of. Now, in the cloud, they call it a shared responsibility model. Why the cloud infrastructure takes care of what they are doing, you, the user, have to ensure that you also take care of your deployment. An example of that is this. I could go to AWS and then create maybe 3 virtual machines, or 4, as in my own case, 4 EC2 instances, and I can take one of them, put my controller, use one as my controller, and use the rest as my worker nodes. Now, the responsibility of making sure that my EC2 instances are secured in terms of which ports am I going to open to my cloud, or to my infrastructure, it's all going to be my responsibility. But of course, AWS has to ensure that they take care of the actual server where those instances are running. AWS has to take care of the server, they have to take care of the hypervisor, they have to take care of the storage, any other thing that is required for my EC2 instance to run in the cloud, they have to take care of that. So if I were to create these 4 instances in AWS, it is my responsibility to make sure that this is properly taken care of. And of course, the best place to consult for that is the documentation for the cloud you're using. If you're using AWS, yes, you need to go and check the AWS documentations on the best practices on how you want to secure this infrastructure. If it's Azure, it's going to be the same thing. Okay, so those are the 4 layers you have to that we can understand our security perspective from. So from the diagram so far and from what I've been trying to explain, you can see that an application deployed in Kubernetes is it has a lot of layers. It has a lot of moving parts, and so you have to be you have to ensure that you understand this complexity as you deploy your environment, because these days, as more and more people move the application to Kubernetes-based clusters, it means the eyeballs are moving to Kubernetes. And there's a common say that where the eyeballs go, that is where the hackers are going to go as well. Excuse me. And so learning Kubernetes from my own perspective is not enough to say you know how to use Kubernetes. You need to be aware of the security posture that you can do to make sure that your applications are secured. Also, you need to ensure that you take security not like a one-off. You have to take it as the entire life cycle of your application. The entire life cycle of your application. So security is not something you do once and then you return, then you stop it. You have to make sure that you take it throughout the life cycle of your application. And AWS is one company that can say that, always talk about this kind of concept. AWS will say that security is our job zero. In other words, as soon as they think of bringing on a new service, they will first of all assemble their security team. The security team will go to work and they have to start to think of how to secure this service. So the security team will go to work, make sure they bring all the necessary recommendations before anything will start. So they incorporate security throughout the entire pipeline. And in fact, these days, even though people do DevOps where the application deployment is so frequent, people are also looking for ways to incorporate most of these things we talk about into their own pipeline. For example, it's a common practice these days for people to include an image scanning software into their own pipeline. So as soon as you create your image and deploy it, you want that infrastructure to scan the image, make sure that the image passes all the recommendations before that image get deployed. Okay, and again, we can encompass this concept with what we call the DevSecOps. DevSecOps means that it's not just about DevOps. Whenever you think about an application, the security team has to be on board as well. So that is why we have three words: Dev, Sec, and Ops. Before we talk about DevOps, now it's DevSecOps. So security cannot be left until the deployment time. You have to start thinking of security right from the day one that you are thinking of deploying this microservice, this application you have right here. Otherwise, you stand the risk of this application being compromised or being hacked at some point. And if you get hacked, then of course, you're maybe going to get some of your assets are going to be stolen. Maybe your reputation will be at stake. And if you are under compliance with maybe HIPAA or PCI DSS or any of these other regulations that are common, then you are going to be in trouble. You have to go through a lot of loopholes or processes or procedures to clear yourself. So I would say that generally, if you're managing a Kubernetes environment, it's not enough to say that you know how Kubernetes works and you know how to deploy it. You need to look at all the security measures that we'll be talking about. And like I said, this is a big area. You have to start with the code and go to the container infrastructures, which we can talk about the millions of things here. Then the cluster, which talk about within the Kubernetes infrastructure, which is also a complex. Kubernetes can be quite complex because it has a lot of moving parts. So understanding all that is interesting. And by the way, the CNCF is also putting a lot of effort into security these days because they just came up with a Kubernetes certified security specialist. Okay, so if you take the certification exam, you're meant to be a specialist on Kubernetes security. And of course, you have to go through these 4 layers that I'm talking about here to ensure that you understand all the different layers of Kubernetes. All right. So like I said, today is going to be more like an overview. So I'm going to talk about a few things under the cluster. We're going to go back to the architecture here to talk about a few things that I mentioned. The API server, how do we secure it? What are some of the things you could do? The etcd server, and then the kubelet. And then after that, I will pretty much round up. And then in the next meetup, I will, deep dive into something more. More is going to be like, now we talk about the Kubernetes infrastructure. We'll start talking about things within the Kubernetes infrastructure. Things like RBAC, role-based access control, things like network policies, things like PSP, port security policies. There are a whole lot of stuff that we'll be talking about. And even Istio. Istio is now like the overall software where people tend to deploy to take care of their security within the Kubernetes infrastructure. Okay, so let's talk about some of this and then we will round up. So I'm going to start with the Kubernetes API server. Now, this is what I was saying earlier, that some of us are new, some of us have been working with this. Other than that, really to talk about Kubernetes security, you need to be aware, you need to be familiar with the architecture and how it works. So because if you don't, it might be difficult for you to know where to fit in within the security, where to fit in security. But of course, starting now, if you have this awareness that security is going to be very important as you study Kubernetes, then that will also help you. But I mentioned that because when you deploy Kubernetes, okay, you are going to use a tool. Mostly people will use a tool to deploy Kubernetes. The one I deploy here, I use a tool called kubeadm. So my discussions are going to be mostly from kubeadm perspective. But if you use something else like kops, another deployment tool is called kops, K-O-P-S. If you use that tool, now the way you look at security may be different because the way every deployment tool manages the security aspect is slightly different. Some are very lenient or a little bit lenient. Some are more like tuned for production. So if you use a tool that is well tuned for production, you may think that you are set to go or good to go, but a lot of times it's still not the case. You still have to look into some of the things that you could change to make your deployment even more secured. Okay, so I'm going to talk mostly from the arguments you can pass to your Kubernetes API when you are deploying it. Okay, and like I said, I use kubeadm here so I can show you the kubeadm file and show you some of the arguments that were passed onto this and show you some of the recommendations that people will want you to have. Okay, so let's go here. I bookmark the page if I can find it quickly. And I'm going to look at when you deploy your API, you're going to see a lot of options to pass on to it. Okay, so here, this is right from the Kubernetes documentation. Now, if you see here, and actually, somehow these are not as many as they used to be. Maybe I didn't find the right page, but at least you can have an idea of how many options you can pass to your Kubernetes API server when you are deploying it. Okay, right from top to the down. So there are lots of them, and like I said, I think there are more because yeah, this is not the one I normally see, but there are a lot of options to pass. Now, like I said, depending on the deployment tool that you use, some are going to pass some, and then anything that don't pass is going to be default. So if you look here carefully as you read, some are going to be default. For example, allow privilege user, it says false. So if you don't set it to be true, then Kubernetes assumes it's false. But maybe you don't want to allow privileged user to run anything in your infrastructure. So if you think that your deployment, just because you deploy Kubernetes, is secured enough, not always. In fact, most of the time, not the case. You need to, allow someone who understands enough of Kubernetes security to still go and do an audit. And actually, there's a tool now called the KubeBench, K-U-B-E bench, that you can use to benchmark your deployment. When you benchmark your deployment, it will give you a report. So based on that report, you can know what is good and what is not good. And then you can go and tune it. Other than that, I will never advise anyone to deploy Kubernetes and then use the default deployment that came with the deployment tool, because that is almost all the time not going to be sufficient, especially if you have any compliance requirement that you need to meet. So all the options are here, and as you can see, there are quite a lot of them, and my aim is not to confuse you, because maybe most of you here are not even Kubernetes administrators, but just to be aware, okay, of the things you need to be aware of maybe when you start doing any stuff like this. So there are so many arguments, and I can show you the ones that were passed to my Kubernetes environment. I'm going to be root, otherwise it might not allow me to go there. So here, because I use kubeadm, all my deployment tools are going to be based here on here. They're going to be stored, all my manifest files are going to be stored here. And if I open this one here, they're called a kube API server, you see the options that were passed to my API that is currently running. Okay, so these are the options that are passed. But if you look at this, the list I just showed you, there are so many of those options. And so any of those options, which is not specifically mentioned here, Kubernetes assume the default. And the default may not be what you want. That's what I'm trying to say. So the point I'm trying to stress is that a lot of this comes down to when Kubernetes is deployed. Because when the cluster is deployed, if you don't make sure that certain things are turned off or turned on, then you could be in trouble. The good thing with Kubernetes generally, though, is that if you look carefully here, you're going to see a lot of certificates. Kubernetes uses certificate for communication between the components. And again, if I go back quickly here to the architecture, none of these components can talk to each other without a certificate. If the kubelet needs to talk back to this, you need to use a certificate. If this needs to talk back to this, it needs to use a certificate. In fact, in the case of this, we do what we call the MTLS, mutual TLS. You need to ensure that etcd server authenticates kube API, and also kube API authenticates etcd. So it's going to be two-way communication, authentication, because this is really very important. So all of them uses certificates. They use TLS to ensure that the communication between the components are actually secured. And if you were to deploy Kubernetes manually, you have to create all those certificates, including your certificate authority file. Now, if I go back one step here, you see there's a folder here called PKI. If I go into PKI, folder, you will see that there are a lot of certificates here. Okay, you can see that there's one for API server certificate, etcd has a certificate, API server has the key and the certificate, on and on like that. So the client, which is pretty much, well, this is going to be your certificate authority. Oh yeah, the kubelet. This is the one I'm looking for, the kubelet. So if the kubelet needs to talk to the server, you need to present a certificate as well. It doesn't matter how many times you're trying to communicate. Every time you have to do that. Then if you go under its etcd, you will see a lot of more certificates that are created here. Now, because I use a tool called kubeadm, all these were created automatically for me. But if I were to do this manually, then I have to make sure that I actually generate and create my own certificates before I start deploying Kubernetes. Okay, so that's one thing. The good thing is that everything uses certificates. And from a security perspective, that is, that's one thing not to worry about, because already you created certificates, you expose your APIs on a HTTPS endpoints. You are not going to expose any of your Kubernetes services on an unsecured endpoint. And what some deployment tools do, though, is that they might expose the external communicating endpoints on HTTPS, but within the cluster itself, they might try to run a different port. And because they don't expose it outside, they might want to make it, they might want to run it on HTTP. Again, depending on your environment, that may be good, that may not be good. Some people will either decide to make sure that only the ports that are exposed on HTTPS are actually allowed for communication, and every other thing is disabled. So we're going to see the option here as well in the communication where they specify that. Okay, so let's go back to the file, the configuration file that I was showing you earlier. So we go to manifest, and then we have here the kube API server. Okay, so all the options are passed here. You can see, for example, if you don't put advertise on this IP, then every other IP on your server could be advertised on it. If you had more than 2 interfaces, they will all be advertised on it. So what if you don't want that to happen? And maybe your deployment tool didn't specify this, then the system might assume what is the default, and maybe default is run it on all the interfaces, expose it Kubernetes on all the interfaces, and that may not be what you want, like I was saying. So here we have also something called authorization mode. It's node and it's RBAC. So this is using two, node and RBAC. Usually node is saying that every Kubernetes node, like the worker nodes that I showed in the architecture, every one of this node can only change what is deployed on that node. Now, if you don't put that in your configuration, then if something is created here, this can change it. And that you are increasing your attack surface. From security perspective, you want to make sure your attack surface is very, very small, because that makes it harder for people to go into. But allowing this kubelet to make change to a pod residing here or here, you are basically increasing your attack surface. So you want to make sure that you don't allow that to happen. Then role-based access control. Role-based access control is a big topic in Kubernetes, and I would take a meetup or two to just cover role-based access control. But funny enough, until recently, I don't know the version, maybe Kubernetes 1.10, until then, RBAC was not even the default, and you couldn't use RBAC. So recently, now it's been made a default. So almost every deployment is going to have it available these days. And then you're going to see a lot of certificates, which I already showed you. A lot of certificates are there, which are being used. There's CA.set. This one is there as well. All the certificates that have been used are going to put here. Then this is also here is interesting. Insecure port 0. So this one, the system is not going to allow you to connect to any port which is not secure, which is not exposed on HTTPS using a certificate or a TLS certificate. So if I remove that option, then it could allow me to connect on some other ports, and those ports could be unsecured. Okay, so you get what I'm saying. The basic fact I'm going to communicate here is that at deployment time, don't assume that everything they set is enough, because there are so many options you can pass to Kubernetes, and anything you don't set is going to assume the industry default set by the developers. And a lot of time, that is not going to be what you want. All right, so that is it with this file. Mostly you control everything from there, which means you need to understand to a large extent most of these options. You need to run through all of them and see which of them really doesn't go well with your own environment, and then stop that. Another thing you could do, which is recent and really cool, is that you can audit your Kubernetes cluster. Auditing here means that anything that happens, any person that logs in, you have the capability to know. Okay, so who logged in? W, we call it the 5 W's or so. Who logged in? From where did the person log in? When did the person log in? What did the person do? All those type of information you have the capability to know. Okay, to know who is accessing your infrastructure in your environment. Okay, so auditing has been enabled. In fact, I enabled it here. I did it not long ago. So I entered these two lines to say that auditing should be logged. You should send my audit logs to this location here, audit log in var log, and you should use the policy file that is here. Again, not to bore you with the details of that, but let me do it again. Cat. If I cut this file, then if I go to the audit line, I can see that if I go here, I will see my policy file. So I can do vim that file, and that's my policy file. So in here, you have the option to restrict a whole lot of stuff, or at least, sorry, to log a whole lot of stuff, to audit a whole lot of stuff. For example, we can decide to log anytime a user sent a request response. It can either be request response or metadata or none or request. So none, request, metadata, request response. All of them are different layers of logging. Request response is the highest. In that way, any request that comes into your Kubernetes cluster, any response that goes out, is all going to be audited and stored in a file. So already, even though it's no longer enabled this feature, if I go to var log, if I cut my var log, the audit log, file log, audit. Let me see the name I call it so that I can be sure. Okay, audit.log, audit.log. So you see, this is what Loki would have done for you to make this easier for you to pass through. So now any request I made to my API server is being logged, and this will continue to happen. But of course, with anything like this, you have to be careful because it can easily consume all your hard disk space. This is typical admin stuff. So you have to make sure that you try to rotate this log every now and then, and it gave you the capabilities as well. You can put that in your configuration to say you want to audit this every now and then, or to rotate it also. Log rotation, for those of you administrators, is a way to delete some old versions of your log files and only keep the most current. So you can do all sorts of things. You see it's still scrolling through, and this has not been on for more than 2 hours at most. So, but the good thing here, which wasn't possible before with Kubernetes, is you can now audit every thing that is happening within your own environment. Then if you get hacked or breached for any reason, you got your audit trail here to go through and see what happened. And if you have to present this in a law court or whatever you need to do to defend your company name, you can go ahead and use this file to defend it. So audit trail, you can turn it on, and then also make sure that the parameters you are passing to your API server, they are all, you have looked through them and you see what is really good for you to implement that. Okay, so I'll stop at that for the API server. And then for the kubelet, it's the same thing. For the kubelet, you still have to, I think I'm here on my node. This is my second node. One of the nodes that we see there. See, this is node 1. And here as well, if you go to see, let me do sudo su minus. This is deployed on Ubuntu server. So if you go to etc Kubernetes, you can also see the conf file here, kubelet.conf. This one here has just actually just few arguments passed. Yep, those are the 2 arguments passed, just the certificate. At the same time, if I come here and go to a page I bookmarked for the Kubernetes, the kubelet, this is the kubelet configuration options. You see there are a lot of options too. A lot of options you can pass to the kubelet, yet the only thing that the default deployment to pass gave me is just 2. So that means that, all the other ones are by default, and the default may not be what you want. So as you tune your API server, which is the most important one, you also want to tune your kubelet, because the kubelet is the one responsible for everything happening on the node, the worker nodes. So if that is not taken care of, that could also be a serious problem. Okay, so one example here I'm going to show you. So by default, if you run this command, I'm going to go back to node 1. I'm going to run a command here, cat, let me just say history, to grab curl. So if I run, let me see which of them that has no certificate. Okay, so I'm going to run any of this command here. Oh, let me clear this. Okay, so I have a file here. Need to go back to home. Okay, so I'll show you this command here. If I run this command, I'll just say curl. Okay, let me just say curl and give you this URL. Basically, this command is going to try to go to the kubelet and show me some information. But if I run it, it should say it should not allow me because I'm not using the certificates. Okay, but if I were to put the certificate, if I were to put this line that I save here, which means I specify all the certificates that need to be used. So I say curl, I specify the CS certificate, I specify the key I specify the certificate itself, and then I specify the URL to go, then this is now going to run. But ordinarily, if I don't put all the certificates, you see that is now fetching me all the pods. It's just a curl command. Now, if the default installation allows you to run as anonymous, then anybody can go to your cloud and do this, or sorry, to your cluster and do this. But if anonymous is not allowed, which is the case here, because I tuned it, then it's not going to let me run any command until I specify all the credentials that you see me present here on the line. And so some of the things you can tune all could come from the configuration file that you're dealing with. Okay, so each one of these, they have their own file, things you can tune to make them a lot better. So let's go back here. Okay, so in the case of the etcd server, I kind of already mentioned it, because etcd server is where all your information gets stored. In Kubernetes, there's also something we call secrets and config maps. In secrets, everything, well, you have the option to not to pass information, your password, to pass them in clear text. So Kubernetes gives you something called secrets, whereby you can create your maybe password or token or certificates and things like that, and then store them in the secrets, which then get stored here. So if you want your application, maybe one microservice, to log into another microservice, you can pick the secrets and use it. And the information is not going to be in clear text, because you already create a secret, which means the system already converted, encrypted somehow. Okay. The default, the way Kubernetes does it by default, people say it's not the best, it's not very secured, but still, anytime you create secrets, it doesn't matter whether you use an external tool or the tool within Kubernetes, all of them get stored in here. So if someone hack into your cluster and they get access to your data store, not only are they able to get some of the username and password and every other thing that are stored here, but the secrets that you use to log into all your microservices are all going to be exposed and compromised as well. So you need to ensure that this is properly secured. And I mean, this is like MySQL or Oracle, okay, except it's not that big. But still, if you're managing a Kubernetes environment, you need to ensure that you understand how etcd works very well in terms of how do you manage it, how do you take snapshots, how do you take backups, how do you restore, all sorts of things that DBAs do. You need to ensure that you have a good knowledge of that. But most importantly, from security perspective, you have to ensure that you have a mutual TLS between here and here. Okay. The good thing also, though, from Kubernetes perspective, is that only the API server can talk to this. No one else in the whole world can talk to this except the API server. And that means that if the certificates here are not compromised, if they are done properly, especially with mutual TLS, then to a large extent, you are safe. But it might be a good idea too to read more about how etcd does its own security, and then try to implement those in your own environment. Because again, the default that comes with Kubernetes, that is deployed here, may not be what you want, may not be sufficient enough for your own environment. Okay, so those are the things I want to talk about today. Making sure that your API server is properly secured, irrespective of whichever deployment tool that you use. Making sure that your etcd is configured properly. Making sure that your kubelet also has all the parameters properly tuned so that no one can break into your system. Because these three things, as I mentioned here, if someone break into your kubelet, then they can launch their own environment, or they can inject stuff into your own environment. They can even escalate their privileges and do a lot of stuff here. If someone log into your API, break your API server, well, this is the door to your Kubernetes environment. So pretty much if someone breaks in through here, then everything inside is going to be exposed, because from outside, you can only talk to this. And if someone breaches into your etcd server, your secrets and all your other assets that are stored here will also be a danger. And also at the infrastructure layer, the components that connect to your cloud environment, you need to ensure that these are all properly protected as well. yeah, we have something we call the principle of least privilege generally. So the principle of least privilege says give a role or a role to someone just to enable that person do what the person needs to do. No more, no less. So you need to ensure that these EC2 instances, for example, that you're doing here, if it's AWS, that you don't give them too much permissions to do stuff. Okay, just give them what they need to do stuff. Yeah, that will also keep you safe. Okay, so generally what I wanted you to know today is understand the architecture, because if you don't understand the architecture, how can you protect it? And the architecture, even though you've seen it drawn this way, can be summarized in what we have here in terms of the code, the container, the cluster, and the cloud environment. So learning to make sure that each one of these layers is protected is a challenge on its own, but it's something you have to do to make sure that you stay safe within the environment. In Kubernetes, in security as well, there's something we call a defense at depth. Defense at depth means that you don't just provide one layer for the hackers, you provide so many layers. So if they break one, they have to struggle for the other layer. Then they have to struggle for the other layer, and they have to struggle for the other layer. So here, imagine someone is coming from the cloud environment. They have to make sure they break all the security controls within the cloud before they come to your cluster. And then when they come to your cluster, they will now check whether your API servers and all the stuff we talk about are actually properly configured. And then after that, they can now come into your containers to make sure that everything is good. And if all this gives them easy, then here's a target. Then they're going to have a good time to dig into your asset and steal them, but you don't want that to happen. So this architecture, defense in depth, is also, well, to understand it is what you see each time you play games, video games. Every game has layers. You have to win at the outer layer and then go inside and inside and inside until you win. So it's like the medieval time where you have the king or the queen is sitting right in the inner circle, and before you reach the king or the queen, you have to kill so many people. When those soldiers come, if you can kill them all here, that's fine. Well, if the soldiers break into this second layer, then you need to fight and fight and fight until you destroy all of them, on and on, until if you're not able to stop them, then of course they'll come and get your king or your queen right here. So it's the same architecture that they use in security called the defense security at depth, which means that you have so many layers so that before people can actually reach the actual target, it's going to take them time to do that. All right, so I kind of went through that quickly. I don't know if it's quickly, it's actually, we're almost near the time that we'll round up. But hopefully that gives you some perspective as to what to look out for as you start to learn Kubernetes. Personally, if I'm interviewing someone for a Kubernetes related role, I'm more interested in how you are versed in these things, because this is Kubernetes. Deploying it is not enough. You have to secure it because you are protecting your asset. Like I said, everybody's moving to Kubernetes. So this is where the eyeballs are going to roll. All right, thanks guys. That's what I have to say. Let's see, Himanshu, if you have any question, then we can go through them. Other than that, we're going to round up for today.
Yeah, no, Damien, we don't really have any questions. I think it was a really very detailed walkthrough of the security aspect that was really very informative. And I think we're looking forward to actually see what else you have in the future to cover on the same track. That'll be very exciting.
Yeah. Okay. Thank you. So really, if there's no question, if anyone has anything to say, Ed, you want to add anything? Otherwise, we're going to round up.
I mostly just wanted to say thanks because I enjoyed that. Over the last few months, I've been setting up a Raspberry Pi K3S cluster. And it's kind of funny the amount of things that I do in Kubernetes every day and the things that I don't do, and this gave me an opportunity to get a lot closer to how our RBAC stuff works, and I've been recently learning a lot of this, so I kind of wish I watched this 2 weeks ago now, but it was really helpful in retrospect for sure. Thank you.
Yeah, thanks, Ed.
It's cool.
Yeah. All right, guys. Thanks so much for watching. Thanks for coming. Thanks, Himanshu, for all the help and support. So there's no question. I hope to see everyone again on April 21st. Till then, stay safe, use your mask, and I hope to see you then.
Sure.
All right. Okay. Good
Thank you
night
so
and
much,
bye.
everyone.
Okay. Bye.